In this video, I'm going to show you how to convert recurring decimals into fractions. So we're going to start off with a very simple one. We're going to start off with 0.7 recurring. Remember, this dot up here means that that 7 actually goes on forever. So that's the same as 0.777, and 7s actually go on forever and ever. They never stop. Now, if you look at this decimal, it's just one digit that's recurring. It's a 7. The 7 is going on forever. So to convert this recurring decimal into a fraction, write down your 7. That's the top number on the fraction. That's the numerator. On the bottom of the fractions, you always put 9s. And if it's one digit that's recurring, you put 1, 9. It's always 9 on the bottom. That's how these recurring decimals work. And 7/9 is the same as 0.7. If you've got a calculator, well, on the calculator you could do 7 divided by 9, and you'll see that you get 7/9 as a fraction, and as a decimal 0.7 recurring. They're all the same thing. So we've got one there. 0.7 is the same as 7/9. If we look at another one, if we look at 0.3 recurring, now you may already know what that one is as a fraction. Well, following the system we've done up here, it's one digit that's recurring. It's just a 3 that's recurring. So we'll write that down. And because it's just one digit that's recurring, we write 19 on the bottom. So 0.3 recurring is the same as 3/9, 3 over 9. Now you might be expecting 1/3. Well, let's have a look. 3 over 9, 3 goes into both of those numbers. 3 goes into 3, and 3 goes into 9. I'm just going to put that 3 down there in a circle. I'm going to divide both of these by this number down here, by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So 0.3 recurring is the same as 1/3. If we look at another one, 0.63 recurring, if the dots are like this means that that number is 0.63636363, and so on, and the 6s and the 3s as a pair go on forever. So we'll write the 6 and the 3 down on the top of our fraction. That's our numerator. And on the bottom, we write 9 down twice. So you get 99. We've written down 9 down twice because there are 2 digits on the top. So 0.63 recurring is the same as 63 over 99. Now hopefully you can spot that both of these numbers have a common factor, a number that goes into them both, and 9 goes into both of those numbers. 9 goes into 63 7 times, 9 goes into 99 11 times. So that's the same as 7/11. And again, if you go for a calculator, and we put in a calculator 7 divided by 11, some of these calculators these days will give it to you as a fraction first. Then on a calculator like this, if you press this SD button down here, that will then change it into a decimal, and you've got 0.636363. So we've done a 2-digit recurring decimal. So what we're going to look at next is a 3-digit recurring decimal. And you've probably guessed what will happen. This is 0.201, and I'm going to put the dots there and there. That shows that the pattern recurs between the 2 and the 1. So that's the same as 0.201, 201, 201, going on and on forever. You probably guessed what we do. We write down the 201 on the top as the numerator of our fraction, and on the bottom we write 1, 2, 3, 3 9s to get 201 over 999. Now, you may be able to spot 3 goes into both of those. 3 goes into this number because 3 goes into the 9s. 3 also goes into 201. Just as an aside, you can check that because 2, 0 and 1 add up to 3. If 3 goes into 3, 3 will go into 201. And as you do cancel that down, dividing them both by 3, you'll get 67 over 333. And that's what 0.201 is as a recurring decimal. Sometimes you can get them slightly harder. If we look at this next one, 0.04 recurring, where the dot is over the 4, but not this first 0. That means my number is 0.0, and then the 4s start going on. Well, if you get one like this, think of it like this. 0.04 recurring, that's the same as 0.4 recurring divided by 10. So if I'd move this decimal point here to make this number 0.4, well, this number here is bigger than that one, so I've got to divide it by 10. So 0.04 recurring is 0.4 recurring divided by 10. This is 4 over 9, and I've got to divide that by 10. If you're dividing a fraction by 10, all you need to do is put a naught on the bottom. So that becomes 4 over 90. 4 over 90 you could cancel down as 2 over 45. So that's how to do one where not all of it is recurring. We'll look at another one of those. The next one we'll look at, we'll have a look now at 0.0045 recurring, where just the 4 and the 5 are recurring. So that's the same as, you get rid of these noughts at the beginning, it's the same as 0.45 recurring divided by 100. And I've divided by 100 because there are 2 noughts here in the beginning before the recurring bit, so I put 2 noughts here. 45 as a recurring bit up there will be 45 over 99, and I've got to divide that by 100. So if you're dividing a fraction by 100, you just need to put 2 noughts on the bottom after what you've already got. So I get 45 over 9,900. Hopefully you can spot that 5's go into both of these numbers. So if I divide them both by 5, I get 9, and that one is 1,980. And then you may be able to spot that 9's go into both of those. Again, as a check here, 1 add 9 add 8 add 0 is 18. 9 goes into 18, so 9's guaranteed to go into that one. And if you do cancel that one down by 9, 9 goes into 9 once, and 9 goes into 1,980 220 times. If we look at one further example, if you had something like 0.37 recurring, I'll show you that one, 0.37 recurring, where just a 7 is recurring, write that as your normal 0.3 plus 0.07 recurring. You've got to make sure that this 7 recurring is in the second decimal place. Well, this here, 0.3, you know that's not a recurring one, I got that wrong. 0.3, that's the same as 3/10. Over here, this 0.07 recurring, that's the same as 0.7 recurring divided by 10, using what we did earlier on. 0.7 recurring is 7/9. I have to divide that by 10, and I mustn't forget the 3/10 at the beginning for the 0.3. 7/9 divided by 10 is 7 over 90, using the same method as earlier, and over here I've got my 3/10. I now need to add these fractions together. So I'm adding these together, whichever way you use, I'm going to put it over the lowest common denominator, which is 90. 3/10, if I times the bottom number by 9, I need to times the top number by 9, so that's the same as 27 over 90, and my 7 over 90. If I add those together, I will get 34 over 90. If I then cancel that down, 2's go into both of those numbers, I get 17 and 45. So I've gone from my starting number, which was 0.37 recurring, and I've got that down to be 17 over 45. And again, if you're doing a calculator paper, you can do that check. If I do 17 divided by 45, the calculator will give me, as a decimal, 0.3, and then the 7's recur. So I know I've got that question right. So let's go back to see what we're working out we've done there. If you can cope with that question, you can cope with changing any recurring decimal into a fraction.